So, you know, who knows when, and I'm not sure when the person named Kramer lived, but Kramer was probably a physicist or something and was having to solve systems of equations regularly and was solving by substitution or elimination, probably not graphically, because Kramer didn't have a graphing calculator to get an exact answer. And so Kramer said, I notice this pattern. I'm always multiplying this equation by something and that equation by something and then adding them together and eliminating. Now, if you'd rather not see the theory, the proof to behind why Kramer's rule works and we can solve by determinants, you might skip over this next piece. But this is what Kramer said. Kramer said if I would multiply this equation by b sub 2, which is the coefficient in front of the y term. So this a1 gets multiplied by b2. This b1 gets multiplied by b2, and this c1 gets multiplied by b2. And then Kramer said, I'm going to multiply this equation by b sub 1. Kramer could have used a2 and a1, but by multiplying this a2 times b1, Kramer had this statement, this b2 times b1, and this c2 times b1. And what happened then is that these two terms in the middle are like terms. Notice they're b1, b2, and b2, b1 with y. So those are like terms. And Kramer said, let's subtract the second one from the first. So let's change this to a minus sign. And so in the process, what was left here was on the left side was a1, b2, x minus a2, b1, x. This is gone. Those had to be 0. And on the right side, Kramer had c1 times b sub 2 minus c2 times b sub 1. But Kramer wanted to solve for x, and so there was an x term here and here, and Kramer factored the x out of each of those and was left with a1 times b sub 2 for the first term, and then minus the a2 times b sub 1 for the second term, equals, again, this over here on the right-hand side. So then finally, to solve for x, Kramer said, let's divide by the product of a1 times b2 minus a2 times b1, both sides. And Kramer now had this rule. And this rule said that you can find x in any equation if you take the c value, and I'm going to try to scroll up here. If you take this, so I'm pointing up here to this original system, if you take this c value times this b value and then subtract this c2 value times this b1 value and then divide it by, notice the denominator is a's and b's, so it's the a1 times b2 minus this a2 times b1. So both of these are minus. So what I'm going to do first before we go solve a system is I'm going to give you some practice determinants and just practice at evaluating them. So all we're doing is we're going to take a column of numbers that might represent the A1, A2, B1, B2, and we're going to do this calculation right here. But you still probably can't see how I'm getting there. So we're going to take that 2 times the 5. That's going to be like A1 times B2. And then we're going to subtract this product right here, which is a negative 3 times 7. So what you have to evaluate this determinant is 10 minus a negative 21, which is 10 plus 21, and you've evaluated a determinant. How about if you try this one? So, and it's really quite a simple process, but I want to give you one with negative signs. So go ahead, please, and pause the video and evaluate this determinant. It's kind of like cross products. There is a subtraction sign in the middle. Please go ahead and evaluate by taking this product and subtracting that product. Hit pause. Okay, so a negative 6 times 1 is the upper left to lower right. Then you are subtracting a negative 8 times a negative 2, which is a positive 16. So we have a negative 6 minus 16, so the value of that determinant is a negative 22. All right, so let's see how Kramer put this all together. So first of all, how about if we take this system and we solve it by elimination first? So let's multiply, actually I'm going to multiply the first equation by a -1. So this x will become a negative x, the 2y will become a minus 2y, the 7 will become a minus 7, and when we eliminate these x's, we have a minus 3y equals a minus 9, and we divide both sides by a -3, and we get y is equal to 3. If you don't mind, quickly, with y being equal to 3, then x plus 6 equals 7, so x has got to equal 1. Well, Kramer said that to solve for x, that if you would take, let me write this down as a determinant. And I'm going to explain this in a minute. So Kramer said if you would take in the numerator c sub 1 times b sub 2 and subtract c sub 2 times b sub 1, and then in the denominator a sub 1 times b sub 2 minus a sub 2 times b sub 1. Even just check this one and go back a page with me. So, or maybe it's actually, yeah, it's right here. So a sub 1 times b sub 2 minus a sub 2 times b sub 1. C sub 1 times b sub 2 minus c sub 2 times b sub 1. That's what I've got going here. And so what I like to do, I'm going to erase all of this, but I'm just going to keep the x is 1 and the y is 3. So what we do is we come on over here, and in this denominator, we put the numbers that are in front. These are the a's, these are the b's, and these are the constants, the c's, and we put the 1's down here, the 2 and the -1 right here, and we will evaluate that determinant. What I do to remember when I'm solving for x, but you can have this on a note card, is this column is the same as this column. So see the 2 and the -1, I just bring it up. And when I'm solving for x, the first column is these c values. So the c's are a 7 and a -2. I'm now going to take the cross product, and if you don't mind, I'm going to kind of say this in my head. That product is a -7, and I'm going to subtract that product is a -4. So when I take a -7 and subtract a -4, I add 4, so I get a -3 in my numerator. Downstairs, this product is a -1, and then I'm going to subtract this product, which is a +2, subtract 2, and when I divide by a -3, I find out that x is equal to a -3 divided by a -3 is a +1. I could now just take that answer and put it back into one of these to solve for y, but I want you to know that Kramer determined that y can be found by having the same denominator, a1, a2, b1, b2. But when solving for y, the first column comes up and the second column is the constants. So I don't need to do the calculation for this denominator. It's the same as it was before. But the numerator, I'll put in my a values, which are 1 and 1. And then my constants are 7 and a -2. And when I take that product, which is a -2, and subtract 1 times 7, which is 7, I get a -9 divided by a -3, and I find out that y is indeed equal to a +3, just like I had found here. So let me go ahead and just set up this next one. So to solve for x, also one more thing just in case, it has to be in standard position. You have to have the constants on one side and you have to have the x's lined up and the y's lined up on the other side. To solve this problem for x, in my denominator I put this 2 in this 1, I put this -1 in this 5. In the numerator, I put the -17 and the 41. I bring up the -1 and the 5. And let's go ahead and do this fairly quickly. So kind of don't want to make this too long. So a negative 17 times 5 is, I think, a negative 85. And then I'm going to subtract a negative 41 because that's this product, which means to add 41. I'm wondering if it looks like that's going to be 44 negative. So that's going to be a negative 44. Here I have 10, and I'm going to subtract a negative 1, which means I have 11. So my solution for x is a negative 44. When I solve for y in this problem, I'm going to put the negative 17 and the 41 over here, but right here I'm going to put the a values. That's the 2 and the 1. The denominator is going to be 11 still. So I'm going to have that product, which is 2 times 41 is 82. And I'm going to subtract a negative 17, which means I add 17, which means I get 99 divided by 11. And I find out that y is equal to 9. Please make sure you check these answers when you are done. I'd like you to do number 5 on your own, but what I want you to know is that when you solve number 5, you're going to get for the numerator 204, but the denominator is going to be 0. And you cannot divide by 0, so what I need you to know is that there is no solution for this problem because trying to divide by 0 is undefined. We'll do some story problems maybe. I'm still a little unsure about that. I probably will come back and grab the next couple story problems to finish out this section.